We're going to explore how some people see millions more colors than others, why animals perceive the world in totally different hues, and even how our brains can be tricked into seeing colors that aren't really there. So buckle up, because we're about to go on a wild ride through the science of sight. Have you ever wondered how we actually see color? It's not as simple as you might think. Our eyes detect light, but it's up to our brains to interpret that light as color. Think of it this way: your eyes are like cameras, and the retina at the back of your eye is the film. Light enters your eye and hits special cells in the retina called photoreceptors. There are two main types of photoreceptors, rods and cones. Rods help us see in low light, but they don't detect color. Cones, on the other hand, are all about color. We have three types of cones, each sensitive to different wavelengths of light. When light hits these cones, they send signals to the brain, which then mixes those signals like a painter mixes primary colors to create every other color imaginable. Most of us are trichromats, meaning we have three types of cones, red, green, and blue. These three cone types let us see a spectrum of millions of colors, but not everyone has the same set of cones. Some people are dichromats, having only two types of cones, which means they see fewer colors. And then there are tetrachromats, who have four types of cones and can see a much wider range of colors, possibly as many as 100 million different shades. Scientists believe that about 12% of women might be tetrachromats, but it's really hard to test for, so we don't know for sure. Let's dive deeper into tetrachromacy. Each cone type has a slightly different sensitivity within its range. Tetrachromats might have an extra cone that's super sensitive to a specific shade within the red, green, or blue range. This means they could see subtle variations in color that most of us would miss completely. For example, a tetrachromat might see dozens of shades of green in a forest where we only see a handful. It's like having a high-definition color vision system. Now, you might think color blindness means seeing the world in black and white, but that's super rare. Most types of color blindness involve difficulty distinguishing between certain colors, usually reds and greens. About 8% of men have some form of red-green color blindness compared to less than 1% of women. Even though they might not see the same range of colors we do, they've adapted to perceive the world in their own unique way. Speaking of seeing things differently, let's talk about animals. They experience color in ways we can only imagine. Take bees, for example. They can see ultraviolet light, which is invisible to us. Dogs are dichromats, just like some humans, and have two types of cones, most sensitive to blue and yellow wavelengths. And then there's the mantis shrimp. This little critter has 12 different types of photoreceptors. But here's the thing, they don't process color the way we do. Their brains are wired differently, so even with all those extra receptors, they probably don't see millions more colors. It just goes to show that more isn't always better, it's how you use it. The way we see and understand color isn't just about biology, it's also about culture. The language we speak can influence how we perceive color. In some cultures, there are fewer words for colors. For example, the Himba people of Namibia don't have separate words for blue and green. Studies have shown that this can make it harder for them to distinguish between those colors. Even though their eyes are physically the same as ours, it just goes to show that color perception is a complex interplay between our biology, our brains, and our experiences. Our brains are amazing, but they can be tricked. There are tons of color illusions that exploit the way our brains process visual information. Ever seen that picture of the dress that went viral a few years back? Some people swore it was blue and black, while others saw it as white and gold. It all comes down to how our brains interpret the lighting in the photo. Then there's the checker shadow illusion. You've got a checkerboard with two squares, one labeled A and one labeled B. They look like totally different shades of gray, right? But when you connect them with a gray bar, you can see they're actually the exact same color. So next time you look at a rainbow, remember, it's not just what your eyes see, but what your brain decides to show you. There's still so much more to learn about this incredible sense, and we'll definitely be exploring more cool facts about color in future videos. So make sure you hit that subscribe button and ring the notification bell so you don't miss out. Thanks for watching.